Yo, what's up? Good morning, good morning. Hopefully we won't be having any streaming issues today, but I've tuned some settings this weekend, so please let me know if you notice something. My stats could look better, but yeah, we'll see how it goes. So we had a 2-day, I think last stream was last Wednesday, and we were fighting with this shader a little bit longer than I would like to, but that's usually how it goes. The idea is that this shader is going to be used for the eyes to this stone-ish creature. We're gonna make it look sorta like a old school marble, glass marble. So we have this a little bit of a 3D effect going here. Would like to maybe we can fine tune it today, and then we can fix this issue, and we can also make it flip here. And then we should call it done with the 3D effect. So then we can add some better outside shading, make it look more glossy or glassy. And then we might as well also do a custom texture instead of this placeholder in the middle here. Make it look a little bit more like a marble. And then I'm also thinking about, but I'm not entirely sure about this one just yet, but do a shade the background as well. Make it into sorta a make it appear as if we look through the marble and see the backside of the marble. Okay, let's open this one up and see what we have. Don't we have... Okay, we don't use this one anymore. Yeah, improve. Okay. Let's keep this one as is. Don't worry about these issues. So this one right here, if we return the UVs, we can see that something fucked happens over there. I wonder why. We get extremely big values over here. Let's see. We want to do inverse lerp 01. Which is okay, I guess. We get this one instead. Thought we could get rid of it by limiting this one. Okay, never mind. I wonder where it comes from. Like, what? UV, I'm gonna print those again. Okay. So what do we have? Is that... Am I misunderstanding something when I do this? So pretty much define a plane with within these x coordinates and these y coordinates, and then we just inverse. So we get a UV coordinate in 3D space. Not really. Hey, what's up, Clara King? Hope you had a wonderful weekend. It's going okay. Just started trying to get back into it after a few days away, you know. What's up, Julius? That's the better type of plane, not the one we're working with here, unfortunately. Yeah, we pretty much get UVs from this method. It's only that we want to... So the ones we get here goes from -1 to +1. Also have this issue. I wonder if it would be enough. Wonder if it would be enough to do times 0.5 plus 0.5. Okay, definitely not. Think. So what's the difference between this and this? still the same issue and way worse here. So this interpolation we're doing here seems to be working fine. Except for this angle. Okay, so we're not talking about UVs above 1. That's good to know. Or actually, we should be. These two should limit x and y between 0 and 1. What I was wondering is, we're gonna see if mipmap, yeah, get the fuck out. Of course. Of course. I remember last Wednesday that I thought it could have to do with the filter mode and an ISO level. Which I guess then it is, but I just don't know in what. Okay, look here. Generate mipmap. If we don't generate mipmap on this one, how fucked is it gonna look when we are? I don't even know if that's something we need to do. So now we have MIP. I don't know. Like, I think we could do without MIP maps for this one. But that feels like we're not solving a problem. We're just... in some ways, I guess we do, but like it feels like we just remove the cause of the problem without actually understanding how to properly solve the problem. If you just skip the MIP map. One sec. What with the MIP map makes... Okay, we're looking at the texture from a very, very steep angle. Which I reckon makes us read from a very, very low resolution MIP map level, which means that a UV of, for instance, 0.1 actually has some color, and that's what we're seeing here. Fade out to gray. MIP map limit. Well, could we do... Clark King sent you a link on Discord of a tutorial I found on how to create ice. Oh, beautiful. We'll look it up after the stream. I wonder if I can open it up. Let's see here. Pretty fucking cool, actually. We'll definitely look it through in greater detail after the stream. Don't know if... It's not exactly what we're trying to do here, but we could probably get some tips and tricks, I reckon. but I say that I haven't looked it through in greater detail. So what I wonder if what we can do here, if we can just limit it. If we're above a certain angle, we pretty much just don't read from the texture. We just return black or whatever the background color is supposed to be. So I guess we could do if so if it's this, then we do this. Otherwise, we just have content color 0, 0, 0, 0, and then we get rid of this one. So that's great. A little bit better of a solution than this, I reckon. I wonder if yeah, I'm okay with that. Although, might have been a little bit too aggressive, I noticed here now. Also find that bit weird. Okay, that's one issue solved. What more did I say? I'm still not. Yeah. Okay. I want to look through. I know that we maybe spent a bit too much time on that last Wednesday, but I want to look through this method again, where we rotate around this. I want to work with it a little bit. I want to see here. What I worry about the most, or what I want to get in place the most, or one thing I really want to fix, is we want to lock this one around here. I will never want it to be able to get to this point, but we want to lock it here. And then we're going to get a flip, but yeah, we're going to get some losses. Although I wonder, doesn't it look like... First of all, the UVs are flipped here, right? Maybe we want to fix that. So let me just write some issues here. We want to fix... Maybe it's time to add back the to-do we had here. One sec. So I want to do fix 3D fake interpolation. Mirror and flip UVs, because we're currently displaying it flipped horizontally and flipped vertically. Right. Yeah. What more did we have? Add proper mirroring, or no, add proper backface rendering. Okay. Oh, we actually have this one committed. Okay. One thing I find, so these bounds here, I must have done something very wrong with these bounds, or that the UV coordinates for point in plane, could it be that when we calculate plane tangent and plane binormal, that we're doing it the other way around here? Let's check it out soon. I just want to commit real quick. And then we're going to distort this shit as well. I think I have a refraction. Do we have util refraction? We have reflection, but not refraction. We'll probably, yeah, we'll probably implement refraction HLSL. So I want to have methods where we just send in original UVs, view direction, texture and stuff like that. Because we're doing a lot of refractions, or we're gonna do a lot more even. So it might be good to just have a file we can include, just like reflection. But okay, let's see. So this fix here, we just fix so that remove remove weird content rendering at steep angles. Pretty much. Okay. Let's see what we can do about the UVs then. Because we're currently flipping it, so I want to check. Okay, I removed it, but let's add it back again. UVX, UVY, 0, 1. So we can see here that this one should be here. And this one should be here. So what happens if we bounce X, bounce Y? One sec, be right back. Bye. Sorry about that. Julius, what do you think about AI? I always think let's just ask GPT to write this, especially Elrich low-level code stuffs. I love AI. use it sometimes, have had more success with it when I do web dev stuff compared to game dev stuff, especially shaders. It's still not, I try to like involve it a bit more in my work, but it's still not my go-to, you know. We're gonna look into some, maybe we can get some AI working within VS Code eventually. I can't say I've tried it a lot with shaders, but the few times I have tried it with shaders, it has given me instructions that are straight not possible, you know. But I mean, this method we have here, this one was pretty much, we have changed it a little bit and fixed it, but this was pretty much just a answer from given a AI prompt. But anyway, I want to see what happens if we flip these. Yeah. I don't think we're entirely there. I think we need to flip it like this now. This one is actually correct. This one is... Fuck, isn't this correct? I'm a little bit worried about 0, 1, 0, 1. Julius, it works every time, 50% of the time. Yeah, classic. How does this make sense? Okay, I see it, maybe. Yo, what's up, PG King? Hope you had a wonderful weekend, man. Fuck these UVs here. Plain origin, plain normal. I don't think my generate tangent is wrong, but... Okay, so if we look at this one, what would I want to do to make this proper? We go from y goes from 0 down here, but does it really? X is 0 here, y is 1. Y is 0, x is 1. 1, 1. Bounds 0.5, 0.5. So we go from minus 0.5 to 0.5. Should be okay. Yeah. Let's double check this one. Okay. Hmm. We would need to do, okay, what would we need to do to make this work? We would need to flip y and x first of all, like this, and then we would need to, is it this one, 1 minus, flip it like that, then we get this. That's not entirely true though. 1. Okay. Oh, is it actually x and y are correct? But we just flip it like this. And then we flip it like this. Why though? So this compared to this. Yeah, what's up, Spires? Hope you had a wonderful weekend and a wonderful stream. And thank you for the raid, appreciate it. Okay, over on this stream, we're currently in the mud, trying to do like a marble-like texture. Or marble-like shader, actually. So we're trying to like simulate something within a sphere, glass sphere. That's what we're currently doing. And I mean, it's going all right. So we're currently generating UVs based on a plane we create in the center of a sphere, and then we rotate that plane given our camera position and view direction, just to simulate something three-dimensional within the sphere. But when we calculate the UVs, we get them flipped like this. And so our UVs we get back goes from 0 to 1, both X and Y, but we want them to go, we want to flip that so it's 1 to 0. This type of error would, or makes me assume that this one is where it goes wrong. But I mean, it can't be unless we actually had minus 0.5 here. So we just take a value between 0 and 1. Because we actually get a value between minus 1 and 1 here. And we want to refit it within negative 0.5 and 0.5. Could it be? Does that make any sense? Does it make any sense? I think it does. Did I fuck up here? Okay, but this is great. So then we don't need to do any hack where we change it here. Now we get the correct point here. We just transform it to a different space. And now we have it. Beautiful. So now it's flipped vertically and horizontally. And we have it like this. Okay, great. Still need more of a 3D effect here, but we'll get to it. So in this file, we don't have any changes, right? Nope, but we do here. Local point. Okay, let me just commit this one real quick. Fix local point calculation in get UV coordinates for point in plane method. Okay, great. So that's this one. Oh, and then add proper front face rendering. We're soon done with the content of this one. Oh, fucking hell, we're gonna distort it. Alt texture position based on... Distort content texture. Okay. So, back to this method and this to do. Should I draw this once again? Hopefully it's not needed. Hopefully we can finish this one way quicker than last time. I think it's as easy as this. Let's see. Yeah, I think it's as easy as this. We have our sphere. And then we have our plane. Our plane has its original normal. And then we're gonna define a max. Red, that works pretty good for max, right? So then we're gonna define its max rotation angle as well. Our task is to calculate what normal this plane should have. How much should it be rotated based on these two? Zero rotation, max rotation. And how much we rotate them, we want to do that based on our camera view, which we invert. So we get something like, draw this one in blue, like this. And then we do an inverse lerp here. So we get does this make sense? We do an inverse lerp here, so we pretty much get how far along here it is. So 0.6 is what this looks like, or something like that. And then we take this 0.6 and we put it into our tween function. So in this case, I guess it's gone, if this is x, we tween it, so we get x times x times x. That's the other way around, right? That makes it smaller. So we have a bit more of a... It starts slow and grows quickly. Now we're going to take a look at the tweens. But anyway, we get a value from this one, y. And this one we use to interpolate between this one and this one to get our final plane normal. The idea is that it goes quick in the beginning here, and then the closer we get to this one, the slower. So a camera angle like this pretty much interpolates exactly to this one. I think this is it. One sec. So let's take a look at one minus x. Okay. Yeah, I think we want to try this one. Okay, so it's gonna look like this. Content texture, and then we want to add object variables. Bounds, plane and normal. Bounds, plane normal. How is it one? Can we just add space like this? Let's see here. Plane normal. Yeah, we have a negative and a positive here. That's true. Fuck. We need to take this one into account as well. But we should be able to, we can just define it as max angle. And then we can check the sign of the camera view direction, so then we know what bound we should have. Or we could... Yeah, maybe that's easier. Plane, max, rotation, angle. Plane max rotation angle, but then we're gonna have to calculate it every frame. Yeah, maybe it's better to just define it as... And if we do this solution as well, we're gonna have to calculate this one as an angle to make it... I don't know how we would do inverse lerp. Hmm. Yeah, we want to calculate an angle here. And then we get this. Oh, yeah. Max rotation angle. I don't know if we're going to do it in degrees or not yet. But I think that's much easier. And then we calculate the degree here. Or the angle here. And then we use that one to lerp. Do we have util math? Signed angle axis. Okay. Rotate around axis. Angle. In radians. Okay. So we can get the signed angle. So we define a max angle, alpha. And we get the angle between the camera view and the original normal. And then we inverse lerp. What is that angle between 0 and max? And then we do that one and put it into a nice tween or transform. And then the value we get there, we use to rotate this normal that much. I think that's it. And which means that we should be getting a quick rotation initially and then slower and slower the closer to this one we get. So a little bit of a fade out. Whatever the tween ease out. Easings. Okay. Yeah, let's try it. What I hate with this though is when we define plane max rotation angle, radians, or do we want it in, it's easier to just do it in degrees here and change it to radians. Do we have remap? Ah, you have that by default, right? Degrees, radians, HLSL. Okay, beautiful. Because I'm actually going to do this. Angle, degrees. Okay, plane normal. We want to calculate all of this here. This is where we want to do all of these cool calculations, I think. Yes. So we're going to start by doing float radians, or max radians. Like this. And then we do it's this one we want to replace. So float sine, let's see here, NV angle maybe. Signed angle between so V1, V2. Let's do plane normal or plane original normal, and view. I want to do view direction OS here. Okay, so then we have an angle in radians and a max angle. Max angle, and we have the angle, and then we want to interpolate inverse lerp, I mean. So T angle is equal to 0 max angle NV angle. And then when we have this one, we want to do the angle is equal to one minus math, not math, but pow. 1 minus T angle 3. And then we take this one. We do final angle is equal to lerp, right? 0 max angle E angle. That's our final rotation. So our new plane normal is equal to, we need to float 3. Our new plane normal is equal to angle axis angle and axis, rotate around axis, yeah, rotate around axis, the angle first for some reason, final rotation angle, and then the vector and or the direction, or in this it's going to be the plane original normal, and finally the axis, which should be, yeah, I haven't really decided this one yet. Yes, of course. One thing I overlooked with this. Yes. We don't only want to do this in the Y, or we don't only want to do this in the XZ plane, we also want to do it in the YZ plane. What's up, Camel? Very inspiring to see you at 305th stream. Yeah, time flies. Okay, still, I want to see if our calculations work. If they work with just one plane, the XZ plane, we can probably extend it to work in both planes eventually. So for now, I'm just going to say I'm pretty sure we know that the normal is 0, 0, 1. So I want to rotate around 0, 1, 0. And then we use this plane normal here, and everything should be fine and dandy, I hope. Signed angle. V1, V2 axis, yes. Similar, same axis here as here. And by doing this, I don't think we see... Yeah, we don't see anything doing this. But... we definitely have some weird stuff going on here. Fuck. 180. Now we're looking at it directly from the front, and then we start rotating here. Here, does it slow down? I think it does, but then it starts... It definitely slows down. What did we put as... One sec. Okay, back. So it doesn't work. Or actually, does it? So we rotate. And it goes slower and slower. And when we are at 180... Now it stops rotating too early. Then it starts rotating with. And we have this issue as well. Fucking hell, thought this was it. Yeah, max angle, we don't have a sign here. True. NV angle, signed angle. Max angle, so what we can do here is sine NV angle. It's this one. So now it works in both directions, and I think we rotate quick at first and then slower and slower, definitely. But then for some reason or do we do it slower and slower? Maybe we don't. Or does this not make sense? Yes. Do we get... How does this make sense? Or like, I wonder what's causing... It's the back rotation I can't seem to explain. So when we rotate around it, it looks pretty good. One sec, we're moving in the wrong direction as well, aren't we? Yes, we are. Really? Like, here it works, does it? But we're moving in the wrong direction. Huh. Okay, that explains it a tiny bit. Okay. And then we do final rotation angle. It rotates way too much, way too quick. Doesn't it? We don't rotate more than we say. At least that's one step in the correct direction. 90, for instance, brings us here. That's good. We rotate way too much, but does it? Way too quick. What the fuck is going on? Yeah, so if we have a max angle, yeah, I'm pretty sure we want to have a max angle we rotate. So we have two different spaces. So red is... White is plain normal, red is max rotation. We do one plain normal. And then we have a minimum and a maximum that we... the camera that we take into account. Because otherwise, yeah, we're gonna get... So we're gonna get to 20 degrees quick. Okay. And then we calculate the initial X or the initial T between this one and this one. Then we do space transformations. And then we enter it in this one and this one. Maybe. Plane max rotation angle. Camera max rotation angle. Something like this, maybe. Ooh. We have any rotation now. Let's go crazy 90. That's when we get this fucked result. So let's do plane max is 45. 180. So now we're looking at it from straight in the front, and then we rotate. The fuck. That's a 45-degree max rotation. And it definitely goes quicker here than it does in the end, but not by much. Why are we having... I'm having trouble seeing it in game. It behaves a little bit weird in game, honestly. $180. And we're looking at it straight from the front. We get a sine angle here, then we do inverse lerp. We do this. Which should be... Hmm. Yo, what's up, Apukas? How's your weekend? It was very good, very good. How about yours? I want to see what happens if we do just linear interpolation here. I think we need to add... I'm just gonna add a couple of... Okay, that makes it look a little bit better. I think 45 degrees is a bit too much, though. $30. Yeah, these two help by showing the effect we're getting. Fuck, distortion. Okay, this is pretty good. Pretty good, but it's linear now as well. I think that makes it a bit weird. What happens if we bring back this one? It feels like we have some rotation and then it stops instantly. Isn't this the one we want to do? What happens if we go... Ah, fuck that. It just follows and then it stops. That's pretty much what we get with this one. Extremely weird. Like, does it follow at all here? Okay, this is probably better, I guess. And the idea here is that we flip and then we do it from the other side as well. Okay, it's starting to... Here we have a... We have no interpolation at all at the beginning and then slower and slower. Maybe that's better. Did I think about this the other way around? Is that how we get the visual fake effect of this one following? Because yeah, that is true. Now we're running... Like, I'm gonna have to see which one works best, but... So it's this one compared to this one. I wonder if this one is better. Hey, you know what? Let's do it like this. What do we want to call it? Um, I'm looking for, there we have it. Default cell shade, keyword enum, low, medium, high. Easing function. Camera rotation easing function. And pretty much just want to have two here, but I'm thinking, or maybe we can do quint. Ease in cubic, ease out cubic, quint. You know what? Why not? Ease in cubic. Ease in quint. Ease out cubic. Ease out quint. It's gonna make it easier to compare, but in the end, we probably always just want to have one of them, I think. Okay, where did we have it? Here. What is the new line now? Bada, 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 bada. How the fuck? There we go. Mm. Yeah, let's just do it here. Original, normal, yeah. I'm just gonna send in, we can simplify this one to just float t. Is this something we want to have shader functions? Probably. T angle is equal to calculate parallax normal interpolation T angle. Okay. Is in cubic. And ease out was 1 minus how t. Was it actually 1 minus t? 3. Just want to double check. Yes. And then we have. And then it should be okay. Let's see what kind of. Okay. So then if we rotate this one to about here. And we check ease in cubic, ease in quint. Okay, there's a difference between those two, at least. That's good. Ease out cubic. Oh, big difference. Let's see here. Ease out. In this one, yeah, we interpolate quicker and quicker and quicker. So my question is, does this look... It looks pretty fucking good, actually. But he's out. So in this case, we follow the camera pretty close initially. Maybe a bit too close. Nah, it's pretty obvious that it's ease in we want. I think. Makes it look a bit more 3D. Up until this point then. But at this point, we're gonna do a flip either way. So it's gonna look crazy bad. If it gets to this point, that is. Depending on what's the purpose of this shader. In this, when we're gonna use this one as eyes, it might be better. We never want to look at it from behind. So what happens if we do 120, 90? What the fuck is happening here? Oh, is it because... Like, what is the reason for... So we're starting to slow down, and then it speeds up and rotates more. What the fuck? Makes no sense. Plane max rotation angle decrease 90. So this one should stop at... So it stops at 90 degrees eventually. One sec, be right back. Just gonna get myself a new cup of coffee. Okay, back. Sorry about that. Yo, what's up, Diligence? Fucking hell. These rotation, they just keep getting weirder and weirder, honestly. Let's see what we can do. So if we have a rotation, we limit by plane max rotation, we limit it by 70 degrees and then 90 degrees for camera rotation. Then we get a pretty... fuck. No, we don't. So we still get... like, it continues to rotate here. Is it if we go above? No idea. Yeah, it's if we go above... if we go above 45 degrees here, that's when it starts fucking up. But why? Oh, actually, now when we don't, and we still see this. Hmm. Hmm. Camera max rotation. Let's take a look at this one. Hmm. With this camera, it works beautifully. So we can see... so it starts moving slowly and then stops. Fucking beautiful. Wonder if we do... we don't have it around the x-axis though, but... 90... plane max rotation angle... no, not 90, but 40... camera max rotation angle 120. Plane max rotation angle 40 degrees. Is this... yeah, that's 40 degrees. With this one, we don't have any weird... But this looks pretty damn good as well. So when is it 50? When is it the issues starts? There we have it. Is it when we go above 45 degrees? You can see the little jump here. Why? I also want to compare with if we add none. Rotation easing function. None. Yeah. Final rotation angle 0. Okay, so if we do wind, but if we didn't have any rotation here at all, it would look like not that big of a difference at this angle. Here, I reckon we pretty much have no difference. But I think that's good. But what about if we move to here, maybe? Honestly, not that it makes an extremely huge difference. Fucking hell, I'm having such a hard time figuring out, deciding which one I like the best. I'm pretty sure easing cubic is the effect I want. Looks a little bit flat right around here. It looks good, it looks good. And yeah, I'm annoyed by some of the weird artifact or the extra rotation issues we get above 45 here, and I want to get to the bottom of it, but I don't want to spend more time on it currently. So we're gonna leave it like this because this is all we need for the eyes, and then we will see in the future if we can improve it. So let's just clean it up, commit this shit, and let's see what task we should jump on next. Oh, yeah, one sec. Before we commit this and continue, we might want to solve it in this direction as well. Yes, we could probably just do it very similar to how we're doing it, but we do it on the X as well. Yes, and that's how we're gonna solve it. So we just want to do it 2 times. Let's see, what can we name this method? We can call it Rotate. Rotate towards camera around axis. Wonder if we would like camera max angle and stuff like that, and we probably... Yeah, we can reuse it. And then axis right. Max rotation angle, that's max angle, and then we have axis, which was 0, 1, 0 for the first one. Okay, so now we should just have the same result we just had, but we can reuse it hopefully for it's a minimalistic difference between none and the cubic interpolation. By the way, I'm getting a little bit of a warning here that the audio stream's current bitrate on YouTube is 0, which is fucking weird. So please let me know over on YouTube if you can hear it or not. Appreciate it. Okay, so now I want to see if we can fix it. Rotate it like this as well. And add a little bit of a... make it less plain, you know? And hopefully it's as easy as this now. So we just take this one and we do it again. But this time we do it around X. And I think it works. Yeah, we get this here, but that's okay. Maybe. I think we got it. This is weird though. Mm. When we do signed angle, we should send in axis. It should be okay. I reckon. I get it. Okay, I'm okay with this for now. Do we want to distort it now? Maybe we do. Maybe we do. But how would that look? Yeah, we're gonna use the normal from the sphere. We're gonna do the normal from the sphere. Although I wonder... I wonder if we want to... P... This one right here, camera to fragment ray direction. I think we're gonna offset this one based on normal of the sphere, so we can get some cool... some cool refraction. Just wonder, do I want to implement it here as refraction HLSL so we can include it in multiple different files? Right now we use refraction in, we have a glass shader. Yeah, we do it in some different ways. We have it in the water shader as well, but there we have sort of a iterative approach to it. Yeah, but it's definitely this one we're gonna distort a tiny bit. I want to try and do a distortion where we get the normal of the fragment on the sphere, and then we just do a simple interpolation between this direction and the normal. I'll see what happens. But we're gonna have to invert the normal. I think so. Normal v. Okay, we return normal in world space. In fact, do I want to have normal in object space? Maybe we do. Work with view direction in object space. Position OS, camera position OS. Yeah. Let's do... And we add a new header. distortion. Pukas, I think at the time I was AFK making some tea, getting cold. I get it, I get it. Good to hear and nice to see you back in business. Yeah, it feels nice to be back in business. I was a little bit frustrated last week, so I wasn't able to stream on Thursday because of some scheduling conflict with some real life stuff. And then on Friday I tried to stream, but it didn't really work over on Twitch, so I just said fuck it and took an early weekend. Sometimes you have days like that, right? Apuka's mine as well was pretty good, had some great rest, slept a lot. Sounds like my type of weekend, 100%. During the weekend I started to do a base for localization for my game. Very interested in that. Please feel free to share any resources on localization and your approach to it on Discord. Because I know that I'm gonna have to do it eventually. But I honestly have no idea how I should approach it. Future me problem. Invalid. Yes. So let's just do. Okay. So now we send a normal in object space. We have a distortion strength here. It's a very weird distortion, but so camera to fragment ray direction. Here I think I want to do camera to fragment ray direction is equal to lerp between this one input.normal.os reverted and then distortion strength. Yeah. And then we use this one down here. Let's just see what we get. I'm a little bit... I don't think it can be this simple, but can we get... So the only type of distortion we get from this is... we make it smaller. Not really what I wanted to get. Yeah, might be a bit too optimistic with this one. We're getting some minor distortion, right? I can see some spherical... Yeah, what the fuck? This looks... a little bit worried about this one. Hmm. What I'm thinking here is that it should work something like... We have a plane, and then we have our sphere. And then for this fragment, we shoot a ray. Let's do it from the side. Our plane, sphere. Then we have our camera here. Let's draw it as an eye. So when we render this fragment right here, we check, given this angle of this one, where on this plane do we end up? We end up somewhere around here. So my idea is... Oh, one sec. Yeah, my idea is... that we take the normal of this point, but the inverted, and then we interpolate between like this ray and this ray. So the more distortion, the more towards this one. That might be a bit too easy. We could do reflection as well. Wouldn't it be... Maybe it's a little bit better to do the reflection. Or... Fuck, we actually have... Don't we? Refract. Returns a refraction vector using an entering array, a surface normal, and a refraction index. Yeah, let's try this one, and then we change in refraction index. Refraction index. So instead of doing this weird stuff here, we just do refract. Ray direction, surface normal. Okay, so we do camera to fragment ray direction, input normal OS, and then refraction index. Did I put this one? No. Pukas, yeah, no problem. I will share my approach to localization. I'm not sure if it's the best method, yeah. Like, I just want to see input, like how, like different ways to do it, honestly. But I appreciate it. Let's try this then. So what do we have here? Okay, so that's some crazy refraction going on. With refraction index 1. Oh, fuck. 1.33. Is that for water or something like that? 1 divided by 1. So how do we get this? How do we do 0 refraction? Cameras of fragment ray direction. Okay. We can probably not change this one, or can we? Yeah, I guess we have a little bit of a problem. Line point, line direction. Yeah. Fuck. Makes me want to redo this. Line point. What if this line point here, so right now what we're doing is, this is our line point, and then we do a refract, which means that I think we pretty much changed this whole, like this whole line from this point. I wonder if we will get this point, we use this point, so wherever we intersect the sphere. So instead of using camera position OS here, we use input position OS. Let's see. Same fucked up result, right? Or yeah. Too bad. Doesn't that make sense? So when we hit the sphere, wherever we hit the sphere, this is some black hole effect, yeah? Looks kind of like it. But where does my logic falter? It's like we calculate a direction here from the point we hit the sphere and the camera. And then we calculate this vector here. And then we use this vector to refract against normal here. And then we get a new ray, which we create a line from here. And then we check where this ray hits the plane in the center. And depending on the fracture, or yeah, depending on our refract index, we rotate this point and hit at different points on this plane within the sphere. For some reason it doesn't work. Plane normal. And then we have line point and line direction. Line direction we change based on refraction. Line point we change to be... Fuck, I still think we should be able to... Changing this would be enough. But if we change this one to be equal to wherever we hit the sphere, the way sphere works is that if we're in object space, like the line point in object space and the plane normal, the dot product here will always be 1. This will always be 1. Yeah, but maybe that's okay. Doesn't the preview here look... Oh, am I screwing this up thanks to... No, we don't do this. Am I screwing it up because of this one? Nope. Okay. 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 Yeah. Okay. Um. mm, 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 mm. Interesting. Is this just a matter of... Fuck. Huh. This is weird as hell. Actually... Did... I changed this one here, didn't I? I wonder if I fucked up and that we should have done... and remove this one. And this should be okay, or correct. What I wonder is... okay. And then we add back, let's show this one. And then finally this one. Also, this one is still for the other way. Is it because... Makes no fucking sense, this. But this might be... Okay, let's see what happens with... Do it the other way around. I think... Shouldn't it be the other way around? Make this one smaller and this one bigger. As opposed to whatever is happening right now. I'm not sure about this one right here. But if we do refraction index... No. Get the fuck out. That's not what I'm looking for at all. Okay, we're gonna disable the plain and normal recalculations while we're doing this. I want to see what actually happens here. Why are we getting the backside but not the front here? What am I missing? Entering ray, surface normal, refraction index. Every other calculation works with this as well. It's so fucking weird. Camera to fragment ray direction. Shouldn't it be we're going from camera position to input position. Oops, let's just disable the refraction as well right now. And we have it on the other side. So what if now we go like this? I might have fucked this up. Yes, view direction is the inverter of this one. Did I remove this one? Right, isn't it? But that only matters here. Because we don't use it anywhere else. One more rule. Camera to fragment ray direction, view direction. We don't do anything with this one currently. This one we only use here. Local. Why are we getting this here? On this side. Flipped as well. Yeah, I want to change this one back to camera position OS as well. Oops. But how does this make sense? I don't get this at all. Camera to fragment ray direction. Shouldn't it be the other way around? That depends on what we do in here. Yeah. Plain normal, plain tan. Did I change? This at all? We're gonna simplify it a bit. We're gonna put this one here. What am I missing? Camera position in object space. We just take the world space or camera position in world space, transform it to object. View direction from camera position in object space to fragment position in object space. Okay. Maybe. Should be okay. If we change this one, do we get... Yeah, but I definitely don't want to do that. And we still have the issue of... And we're going to double check this one, actually. Could it be? Plain normal. Yo, what's up, Afonso? How you doing? How you doing? I'm good. A little bit frustrated here because I don't understand this at all currently. It will probably become clear to me tomorrow. Actually, we can print some stuff. Just make it make sense. So let's start with... Fonts are working on the shading. Yeah, we're trying to create sort of a fake effect that we have a sphere with some content in it, and we just want to render the content inside the sphere. It's actually just a texture, but we want to render it in such a way that it looks a little bit 3D, and then we want to add some distortion and stuff like it on it as well. So we're talking about something like this. Okay, so we're getting pure black here because our method get intersection point between plane and line returns this one. So the dot product between plane and normal and line direction is less than 0, basically. Which means that they are orthogonal or bigger difference. Or it means that we have more of a 90-degree difference between them. Plane normal, this one is just our plane normal, 0, 0, 1. So the blue arrow here, straightforward. The line direction is our view direction OS, which is currently position object space. Did I fuck this one up? In output position OS, input position OS. No. So it's currently just the position of the fragment we're rendering and the camera position in object space. And we do a transform world to object on camera position in world space. So it's from this one to this one. But maybe that makes sense. So we have a line going in here. Yeah, maybe it does. Yeah, it does. Don't we want to have it like this? If they are perpendicular, then we don't get any intersection, at least not on the correct. Shouldn't it? It depends on the line direction you do, actually. Okay, let's say we do it like this. We still get... Oh, fuck, do we get the correct one? Oh, we actually do. Okay, so is this how we want to do it? And how does it work with this one now? View direction OS. Get a little bit of fuck like this. What did I fuck up here? N V plane normal. Is that just because we removed this one? Fuck. Yeah. Right here we want to do the inverse here, don't we? I'm pretty sure. Do we have some distortion going on? We shouldn't. Okay. Huh. Why are we getting that? It was up no bullshit. Yeah, unfortunately it is. Or not unfortunately, but yes it is. It's shader day. Probably gonna be shader day tomorrow as well. I wanna get this shader sorta in place. And I've missed doing stuff in doing shaders. V, signed angle. Yes, so here we want to do the inverse, definitely. I do wonder why we're getting this distortion though. Pretty cool. I have no idea. It's interesting though. Get intersection point, play normal camera position, view, intersect. Okay, so what happens now if we add distortion as I wanted to do it? Do we get the correct shit? But I want to do view direction OS is equal to refract, view direction in object space, input normal, refraction index. Maybe. We want to go to 0. Make it a little bit bigger. Oh, yeah, I get it. Interesting. Very interesting. So, let's see, what can we put? Is it 1? Then it's normal, yeah? Yes, okay, what? Yeah, of course. So what happens if we pull it up? Okay, here it becomes smaller. Because our ray hits here, then we'll refract. Okay, maybe it makes sense. 1.33, that's what we have for water, I think. But if I remember correctly, what you want to put in here is... one divided by this. Ah, that's a bit too much, I reckon. One 0.01 or 0.899999. starting to look like something. Doesn't this actually look like it's inside here? Or am I just slowly going insane? I'm probably already insane, but Jesus fucking Christ, what a cool effect. Ooh, it's so close. This one with some proper background shading and foreground shading. God damn. God damn. Okay, but this is weird. What I would like to do is, like, I want to distort the fucking plane inside here. So I still think it's a plane? Or is it? Let's take a look. It looks pretty good, actually. Except it's for here. Ah, fucking hell, it looks good. But it's not... I think there's still... quite a few things to do. Like, I want to bend this one. That's what I want. I want this type of effect you get here, but I also want to bend this one. But I guess that's what we're gonna do tomorrow, because I need to run now. Would love to stay, tinker with this. Yeah, maybe we'll do a longer stream tomorrow. I don't know. But I gotta run. That's the only thing I know. Thank you so much for watching, everybody. Appreciate it. And have a great rest of the day. Peace.